Alright, so last year in grade 9 you spent a lot of time in the course, probably about almost half the course, learning about lines, the different equations of a line, the different forms of it, and a lot of things you could do with it. You could solve equations with it, you could find the x and y intercepts, you could find the slope, you could make graphs, you could go backwards from graphs, and then you had to make equations from various information given. So there's a lot that you guys did with lines, and are going to need to be successful in that in order to sort of dive into the first units. You're going to spend some time here going over most of the stuff you did last year with lines in grade 9. So for starters, the first thing to remember here is that there's a lot of ways you can represent lines, generally with tables of values, graphs, or equations. Just for an example of that, we can take a look over here. Okay, so if I open up Desmos, you'll see I have this table of values here. I've put in a bunch of x values and their corresponding y values. You can see I can put them on the graph, and you can see these kind of follow a linear pattern. It's a very straight line. The equation that represents this table of values will be y equals negative 3x plus 1. So that would be the equation I could use, or I could put that line on the graph and represent it that way as well. So multiple different ways. Usually the best way is by using a graph or an equation. A table of values is a good start, but doesn't give you the full picture of what's going on beyond what's in the table of values. With a graph, you can see everything. Okay, and you also saw a few different forms of a line back in grade 9. So take a second and write down how many you think you can remember. I can think of at least 3 you probably saw last year, so write them out, and when you're ready to see the answers, push play again. Okay, so the three types of equations of lines that you would have seen last year would be slope-intercept form, standard form, and point-slope form. So if you don't remember what those look like, that's okay, I'll go over them now. The main one you probably worked with most was slope-intercept form, and that has the form y equals mx plus b. So that one looks a little bit more familiar to you. If you remember correctly, now in all these x and y are your variables, m represented your slope. Okay, so m represented your slope. Okay, and b over here represented your y-intercept. Okay, so if you had your slope, you had your y-intercept, you could very quickly make slope-intercept form. So if you want to take a look at an example of one of those, we can look over here. So here is the equation y equals mx plus b. Okay, and you'll see what happens as I change the slope. If as m gets bigger, it becomes steeper and steeper and steeper. As m gets smaller, it gets flatter and flatter until m becomes negative, and then you get steeper and steeper on the negative side. So m changes your slope, and you'll see my b in this equation is 1, which corresponds to the y-intercept that's right there at 1. If I change the value of b, you'll see the y-intercept changes with that. So whatever that value of b is, gives me the y-intercept in that equation. Okay. The second form you looked at last year was called standard form. Now it had the form ax plus by plus c equals 0, and there are some other weird rules with standard form as well. So a, b, and c had to be whole numbers. Okay, you weren't allowed decimals or fractions. So I'll just say they have to be integers. Okay, and as another sort of caveat here, a had to be positive. Now, you may remember standard form not being that useful last year. Remember, if you got anything in standard form, usually the equation was put it into slope-intercept form. The reason being, standard form, it might be, there's a way of finding the x and y-intercept without too much work, but in order to get the slope from it, it takes a little bit of work. You got to rearrange the equation into slope-intercept form. So in general, standard form is probably the most useless of the forms you saw last year. So in general, we're not going to spend too much time on standard form. And if you do see something that's in standard form, I would suggest putting it into a form that's more useful, usually the slope-intercept form. Okay, and the third form that you would have seen last year, the point-slope form. Now, I say you saw it last year. It depends. It's not always looked at in grade 9. But it is a very, very useful form, and there's a lot of ways where you can save you lots of time to use it. So in case you haven't seen it before, I'll write out the equation. It's y equals m bracket x minus x1. I'll go over what those mean in a sec, plus y1. Okay, so and what this form tells you, m, just like in slope-intercept form, gives you the slope. Okay, but and x and y are still your variables, just like they were over here in slope-intercept form and standard form. But x1 and y1 over here, these two things hang around, they're just the coordinates of any point that's on the line. So x1, y1 are just any point that's on that line. Okay, and I'll show you an example of point slope form. Okay, so let's go back and take a look here. So you'll see here, let me just erase that one. I have y equals mx minus x1 plus y1. I'm just going to change my x1, y1 values. Let's just say I make x1 2 and y1, let's say 5. So because x1 is 2 and y1 is 5, that's telling me that the point 2, 5 should exist somewhere on that line. And if I take a look out here at 2, 5, you'll see that the line actually does pass through there. Okay, so it's a perfectly valid way of expressing that line. And this could be the case for any point that's on that line. So I don't have to necessarily use 2 and 5. I can use any point that's on there. So let's just say I wanted to use, so I have this point here at 2 and 5. If I find another nice point on here, let's say right here, negative 1, negative 1, well, I could create another equation with that exact same value. And with those, sorry, another equation with negative 1 and negative 1 put in for x1 and y1, and it should give you the exact same line. So here I have a slope of 2, so I'll go y equals 2, and I'll do x, and I had negative 1, negative 1, so I'll have x minus negative 1, so that's going to be x plus 1, and then y1 was negative 1, and you'll see it creates the exact same line. Okay, so whatever the x1 and y1 are, it don't really matter as long as they represent the coordinates of any point that's somewhere on that line. Okay, so we'll get to work a lot more with point slope form. So if it looks a little bit unfamiliar to you right now, that's okay. We are going to get practice with it because, again, in a lot of ways it's a lot faster. We want to try and do things faster, especially in grade 10 and beyond. Okay, so these are the types of equations of lines you saw last year. Okay, so moving on, just again looking at some more definitions that you saw last year in grade 9. One of the most important parts of a line is its slope, and the slope is a measure of how steep the line is. So I showed you back on this chart over here that as you change the slope, you'll see the line gets steeper and steeper and steeper. If it's negative, the line slopes downwards from left to right instead. So the slope is a very important value on that line. And there's two ways of defining it. Well, it's generally defined as rise over run, so how far the line goes up and down for every amount it moves over left to right. Or if you look at the rise as the change in y values and run as the change in x values, you got this slope equation that you used probably a lot last year in grade 9. Okay, so we'll practice using that in a couple of examples. So the x-intercept, if you look at any line, occurs where the line crosses the x-axis. The y-intercept occurs where the line crosses the y-axis. Okay, so just to remind ourselves of a few things of what this actually means. Okay, I'm just going to have you take a look at this equation this equation of a line here. So if you look at the x-intercept, the x-intercept's down here. You can sort of see on the graph that it's at 2. The y value of that point is 0. That's because the point here is on the x-axis. It hasn't moved up or down from the origin, just to the right by 2. So the y value of the point at the x-intercept is 0. Similarly, if you look at the y-intercept, this one is over here at 3, the x value of that point is 0. So when you're looking to find the x and y-intercepts from an equation, well, you just need to remember that at the x-intercept, the y value is going to be 0, and at the y-intercept, the x value is going to be 0. Okay, so if you're ever asked to find the x and y-intercepts of a line, we can use that information. Okay, and last but not least, to determine the equation of a line, we need two things. First and foremost, more than anything, we need to know the slope. So we need to find some way of finding that out, whether it's from a graph or from given points. And once you have the slope, the other thing that you need, depending on the form that you want to create, you may have been taught that you need the y-intercept. Well, that's true. You need the y-intercept if you want to create slope-intercept form, y equals mx plus b. But since it doesn't say what form we want, we just want to find the equation of a line any form we want, we really just need any point. If it's not the y-intercept, that's okay. We can create point-slope form and go from there. If you have the y-intercept, great, use slope-intercept form. But as long as you have any point, you can create an equation of a line that works. Okay, we'll get some practice in that as we go through the examples today. Okay, so just as a bit of a practice here, I want you to try and find the slope of the line passing through these 2 points. And if you're wondering if I was mean enough to give you fractions in the very first example of the year, absolutely I was. Okay, so I'll get you guys started here. Remember that the slope is your rise over your run, so it's going to be y2 minus y1 over x2 minus x1. Okay, and if you remember correctly, if you remember from last year, it doesn't actually matter which one you call point 1 and which one you call point 2 as long as you're consistent. So if I want to make this one point 1, that will be x1 and y1, this one will be x2 and y2. If you want to change that up and have this one be first point, that's okay, as long as you make this one x1, y1, and this one x2, y2. So it really doesn't matter. Just for the sake of finishing what I started here, I'm going to make this one 0.1, this one 0.2. So that makes the 1/2 x1, the negative 1/3 y1, and then the 3/5 here will be x2, and this will be y2. Okay, so I'm going to plug the values in. So y2 minus y1 will give me negative 2 over 9. And it will be minus y1, which is negative 1 over 3. And all that's going to be divided by x2 minus x1, which is 3/5 minus 1/2. Okay, so this is going to be a good chance for you to practice using fractions. It may have been a little while for some of you. So remember to do the subtraction up here, you have to find a common denominator. Same thing with the denominator down here, you have to find a common denominator between these two. So give that a try on your own or with a partner, and when you get to an answer, push play again and see if you got it right. Okay, so first off, I'll let you check your answer. You should have gotten 10 over 9 for the slope. Okay, if you want to see the steps, here's what I did. So the first thing I did, just before I even worried about finding common denominators, is I noticed here I was subtracting a negative up here, so because I have negative 2 over 9 minus negative 1 over 3. So if you're subtracting a negative, that's the same thing as adding. So I just, to simplify the equation, wrote it out with a positive instead. So negative 2 over 9 plus 1 over 3. So then I went about finding common denominators for both the fractions in the numerator and the fractions in the denominator. So between negative 2 over 9 and 1 over 3, my denominators are 9 and 3. So the lowest common denominator there is 9. So if I'm changing 1 over 3 to something over 9, well, if you remember correctly, I go to go from 3 to 9 here, I have to multiply by 3, so I do the same thing to the numerator as well. So 1 times 3 gives me 3. So I get negative 2 over 9 plus 3 over 9. For the denominator, I wound up saying, okay, I've got 5 and 2, so common denominator there is 10. So get from 5 to 10 is multiplying by 2. So I do the exact same thing to the numerator, so I get 3 times 2 to get 6. Okay, similarly with the 1/2, so 1 over 2, so 2 to 10 is multiplied by 5. 1 times 5 gives me 5. So once I have that, I can simplify the numerator and denominator separately. So negative 2 over 9 plus 3 over 9 gives me 1 over 9, and 6/10 minus 5/10 gives me 1/10. This can look a little bit daunting here because you've got a fraction within a fraction, but remember that fractions just mean division. So that's what this big fraction here is, just dividing. So if you find it easier, look off to what I did on the side here. I wrote the division out horizontally, so 1/9 divided by 1/10. And if you remember how to divide fractions, what you do is you multiply by the reciprocal of the second fraction. So instead of division, you can change the expression to multiplication, but flip 1 over 10 to being 10 over 1. Multiply the fractions together, multiply the numerators. 1 times 10 gives me 10. 9 times 1 gives me 9. So I wind up 10 over 9 overall. Okay, so that's a bit of a complicated example to start with, but you know, the whole idea is how to find slope, so doing a little bit of fraction review in there doesn't hurt either. Okay, so let's move on. So if you look in your notes here, you've got 4 different graphs. One with a vertical line here, one with a line sloping down, one with a horizontal line, one with a line sloping up, and 4 different descriptions for the slope: undefined, positive, negative, and 0. So quickly, pause the video and with a friend or on your own, try and match the description to the graph and push play to see the answers. Okay, so you can check your answers quickly here. We've got undefined and negative for the first two, and then 0 and positive for the next two. So why is this first one undefined? Well, a good way to look at it is to take a look at any 2 random points on here. So let's just say I take a look at this point right here, and I don't know, this point right here. So if you look between these 2 points, let's say we're going from this point to this point, there's a rise of 4, so we go up 4, but there's a run of 0. We're not moving at all left to right. So we have 4 divided by 0. And if you try and divide by 0, you'll notice you get an error on your calculator. That's because it's undefined. It doesn't make any sense. So the slope is technically infinite because there's an infinite rise for no run. So this one is called undefined. If you look over here, as we go from left to right, you'll see that we go down 2 and over by, looks like 6. So we're sloping down from left to right. This one's going to have a negative slope. Looking at the fourth one here, going up from left to right, it's going to have a positive slope. And last but not least, if you look at this last one here, a horizontal line has a slope of 0. Reason being, if you look between these 2 points, there's no rise. So we have a rise of 0 and a run of something. So 0 divided by anything gives you 0. Okay, we'll continue this in part 2. We'll see you over there.